Once again, good morning. This is Mr. Kaonga representing Northwise Academy. So today I just want us to look at a couple of exam questions. So now I will advise you, if you never went through my previous video, which was the introduction to trigonometry, because the questions that we'll be looking at today are a prerequisite to the video that I earlier created on trigonometry, where we looked at quadrants, identities, and the reference angles. So therefore, I advise you to say, if you are yet to look at that video, I think it would be of importance to you to go back to that video even before you assess this one, because whatsoever we'll be looking at today is in connection to the other video that I made. So let us look at some of the questions, some of the exam questions that you may be asked in trigonometry. We start. Question 1 says that, this is question 1. It says that prove that tan alpha plus beta is equals to tan alpha plus tan beta over 1 minus tan of alpha tan of beta. Okay, so now recall in my previous video that I made, I talked about compound identities. So now we are going to use those compound identities to prove this particular question. Okay, so we say that, so what we do is that, remember that or recall that tan alpha plus beta is the same as saying sine alpha plus beta over cos alpha plus beta. Okay, now remember that this sine alpha plus beta and this cos alpha plus beta, these are compound angles. So now we know to say this will be equal to, we know to say sine alpha plus beta is the same as saying sine of alpha cos of beta. We maintain the sign, we reverse the order, cos of alpha sine of what? Sine of beta over then cos alpha plus cos beta, the same as saying cos of alpha cos of beta minus, we change the sign but the order maintains, sine of alpha sine of what? Sine of beta. Okay, then if you look at the identity that we have been asked to prove, we have got a 1 there in the denominator. We have got a 1 there, which is 1 minus tan alpha tan beta. 1 minus tan alpha tan beta. So now this one will act as a reference point. Now if you look at now, if you compare the two, that identity that we have been asked to prove and where we are here, you discover to say where there is a 1 and where we are there, we have a cos alpha cos beta where there is a 1 there. So now for us to get a 1 here where we have got cos alpha cos beta, we need to divide this part by what? By cos alpha cos beta, isn't it? That's the only way we can get a 1 here. If we divide this part by cos alpha, we divide this part by cos alpha cos beta. Now so this is acting as our reference point to proving that identity. Now in mathematics, we cannot just divide this part and forget. It simply means that our system won't be balanced. So in order to balance a system, now we are going to say dividing throughout by cos alpha cos beta. we say dividing, we're going to say dividing throughout by cos alpha cos beta, comma, we get so this becomes equal to sine alpha cos beta over cos of alpha cos of beta plus, then we have got cos alpha sine beta over, then we come to cos alpha cos beta. Okay, that is in our numerator. Then we got it to the denominator. Now we say we have cos of alpha cos of beta over cos of alpha cos of beta minus, we have sine of alpha sine of beta, then we have cos of alpha cos of beta. Then we can clearly see that this and this, they cancel. Equally, cos of alpha and cos of alpha, they cancel. Then we can see that this and this, they cancel, this and that, they cancel. So we are left with, we are left with tan alpha plus beta is equals to, so sine over cos, that will be tan of alpha plus sine over cos beta. The angle is beta. Here the angle is alpha. No wonder we have got tan alpha. Here the angle is beta, so it will be tan of beta over this sine cos, cos alpha cos beta. That gives us what? 1 minus, then sine of alpha over cos of alpha. That gives us tan of alpha. Then sine of beta cos of beta, that gives us tan of what? Beta. So this is what we are looking for. Hence what? Hence proved. Okay, so that was an exam question. We can look at another identity. We can solve another identity. We can say prove that this is 2 we can say prove that tan x plus cot x is equals to cos x or cosec x and cos of x. Now, when you are proving an identity, I think it is important to start or to identify the side that appears to be complicated, because usually as we are proving an identity, we move from the part that appears to be complicated towards the part that appears to be simpler. We move from the part that appears to be complicated towards the part that appears to be simpler. So if you look at this identity, I think our left-hand side appears to be complicated. So I'll start with the left-hand side. So starting with the left-hand side, we know to say tan of x plus cot of x is the same as saying tan, we know to say it is equals to sine x over cos x. Then we know to say cot is the same as saying cos x over sine of x. So we can say this is now equal to we can find our common denominator now. So our common denominator there will be sine x over cos of x. So cos and cos they cancel. Cos and cos they cancel. We are left with sine. Sine times sine, that will be sine squared x plus, okay, then sine and sine they cancel, left with cos. Then cos times cos, it will be cos squared what? X. Okay, now recall from the Pythagorean identity that sine squared x plus cos squared x is equals to 1. So in short, what we are having there, we are having this, we are having that tan x plus cot of x is equals to 1 over sine x of then cos what? Over cos x, which is now this is the same again. This is the same as saying, we know to say fractions, permit us to do this. We can say 1 over sine x multiplied by 1 over cos of what? Cos of x. Fractions permit us in doing that. So now we know to say this is now equal to now 1 over sine x. We want to say this is the reciprocal of what? It's 1 over sine x is the reciprocal function, so that it becomes cosec x. So this is cosec x multiplied by 1 over cos of what? Cos of x, which is equals to, now we know to say, now we say we have tan x plus cot of x is equals to cosec x times 1, that will be equals to cosec x over cos x. Hence proved. So we can say hence proved. Hence proved. Okay, we can look at another identity. Which says prove that identity 3 prove that sec of x over cot of x plus tan x is equal to sine of x. So as usual, when we are proving an identity, we start from the side that appears to be complicated, heading towards the side that appears to be simpler. So we start with the left hand side. It appears to be complicated, left hand side. So we say, what can we see? We can see that the left hand side, now we have sec x over cot x plus tan of x. Now what is this equal to? we know to say this is the same as saying, you can say this is equal to, let me bring it here, this is equal to saying sec x divided by, because this symbol there means division, divided by cot of x plus tan of what? Tan of x plus tan of x. Which is equal to, we know that sec is just 1 over cos x, it is a reciprocal, then divide by, we know to say cot is the same as saying cos x over sin x plus tan is just the same as saying sin x over cos of what? Cos of x. Now, following the principle or the concept of BODMAS, following the principle or concept of BODMAS, it is important for us to work out what we have first in the brackets. So let us work out what we have in the brackets. So in the brackets we have cos x plus sin of x over sin of x plus over cos of x. So, and again, our common denominator there will be sin of x multiplied by cos of x. So sin and sin, they cancel. Cos times cos, that is cos squared x plus cos and cos, they cancel. Sin times sin, that will be cos and cos, they cancel. Sin times sin, that will be sin squared what? X. Okay. So now, again, we know to say, recall that, or remember that this, this sin squared x plus cos squared x from the Pythagorean identity is just equal to what? To 1. So we can replace that with 1. We have, therefore, we're going to have 1 over sin of x cos of what? Cos of x. So whatsoever we have in the brackets here, what we are having in the brackets here, it is just equal to that. So we can substitute this for that. So we have, this is equal to, so we go back to that, we can say this is equal to, you can say that is equal to, say 1 over cos divided by 1 over sin x cos x. Now, we know the principle of division, isn't it? So we're going to say 1 over cos x, then this changes to multiplication. So if it changes to multiplication, we find the reciprocal of the other side, or we reciprocate the other side, which is sin x cos of x, then we say over 1. So we can say that cos and cos, they cancel. Then what are we left with? We are left with 1 times sin x, it is sin x over 1, which is just equals to what? Sin of x. Okay. So now we have shown that, therefore we can say, hence proved. Okay, we can look at another identity. We can look at another identity or another question. We can look at another identity or another question. Just a minute, I'm looking for a good question for you guys. Okay. So okay, we can say another question that we can look at is this one. This was question what? So this is question 3. We can look at now. This is question 4, which says prove that sine x over 1 cos x is equals to 1 minus cos x over sine x. Now, identity of this form, because if you look at the left hand side and the right hand side, they are almost similar. Okay, so identity of this form, you can either work with any side. If you encounter an identity of this form, you can either work with any side. Okay, so I will choose to work with the left hand side. But even if you work with the right hand side, it's still fine. So working with the left hand side, I'm going to have sine x over 1 plus cos x. Now, if you encounter an identity of this form, always it is dealt with using the principle of conjugates. Always, if you encounter an identity of this form, it is solved using the principle of conjugates. Now, in this case, we'll be rationalizing the denominator. So we have got in the denominator, we've got 1 plus cos x. So the conjugate of that we know to say, using the knowledge of surds, I think we looked at this in surds. Well, we looked at this in surds. This is just where we change the sign in between. If the sign is positive, the sign becomes negative. So the conjugate will be 1 minus cos x over 1 minus cos x. So you multiply the conjugate both to the numerator and to the denominator. Okay. So this is equal to, so now with regards to what we are having in the numerator, let us not be in a haste to expand, because expansion, what it does is that it complicates the expression. Expanding complicates the expression. So we have sine x over 1 minus cos of what? Cos of x over. Now, if you look at what you have in the denominator, that is difference of 2 squares, isn't it? What we have in the denominator, that is difference of 2 squares, because 1 plus cos x, 1 minus cos x. So this is the same as saying 1 squared minus cos x what squared, which is equal to, we have sine x 1 minus cos x over 1 minus cos squared what x. Okay, but what is 1 minus cos squared x? Recall that that is nothing but sine squared what x is equals to 1 minus cos squared x, coming from the Pythagorean identity that we are given in the previous video that I made. Okay, so if you are yet to check to go through the video, you can refer to the video that I made earlier on. I think I explained this issue of this identity. Okay, so this becomes sine x 1 minus cos x over, we substitute that with sine squared what sine squared x. So one of these and one of these they cancel, we are left with what sine of x. So this becomes 1 minus cos of x over sine of x, hence proved. Okay, so that is that on identities. I think we end here with regards to identities. In my next video we'll look at trigonometric equations, but on identities we end here. So this is Mr. Kaonga representing Northwise Academy. So please don't forget to subscribe to our channel so that you may have more of such videos. Remember to subscribe so that whenever we upload a new video, you are on track with every new video that will be posted or updated on our platform. So have a blessed day. Thank you.